All right, hello. My name is Russell Zimmerman. Over the course of the summer, my mentor, Dr. T. Han, and I have been working on a molecular dynamics simulation of a aluminum, copper, and oxygen system. The two computer systems that we used are LAMPS and Oviedo, which I'll go over in a little bit more detail in the upcoming slides. So just a quick overview of what we're doing. So right away, this software LAMPS is what we use to run this code, these simulations. This stands for Large Scale Atomic Molecular Massively Parallel Simulator. And that's a big long acronym that basically just means this software let us look at various atoms and see how they interact with each other in different circumstances. So the purpose of this research is to save time and resources while developing new nanoparticle strengthening conductors without having to go through the physical trial and error process of actually making them. So aluminum oxide is a hard and very insoluble in copper. So this makes it an ideal strengthening component for copper high field conducting magnets. So methods, this is what I do on a day-to-day. I take electric potential files from the National Institute of Standards and Technology, as well as Susan B. Sinnott's website through Penn State. And I take these potentials of aluminum, copper, and oxygen, and I run them through different simulations through LAMPS. And then I use Oviedo, which is a visualization software. And you can see two snapshots on the right of just a simple simulation I ran of oxygen and copper. And I use these models to analyze different properties of the atomic structure. So results, our specific experiment, our final one, uses a 13,500 atom model of 98.3 atomic percent copper, 1 atomic percent oxygen, and 0.7 atomic percent aluminum. And then we used Oviedo to analyze this using a common neighbor analysis tool. And you can look at the snapshot over here on the right. That common neighbor analysis tool is identifying these white pockets, which basically is just showing how the crystal structure of certain atoms are bonding together. And these pockets of white are showing strong evidence that the oxygen is bonding to aluminum rather than copper. So in conclusion, that this is really good that aluminum is bonding to copper, aluminum is bonding to oxygen rather than oxygen bonding to copper, because aluminum oxide and copper oxide can both be used as a strengthening component of copper. However, aluminum oxide is much more stable and insoluble in copper, which makes it a better strengthening component. So this allows the new nanoparticle to be durable and maintain a very high conductivity. Now you can read through some of the other discussion topics here on the right. The main one I wanted to talk about is the environmental benefits by saving resources through simulation instead of having to physically make it, maybe make a mistake, waste those resources, and then have to make it again. Thank you for your time.